remember one because I even reached out to you and asked for help, but I just cannot get an answer that matched one of theirs.
Okay, that's fine. I can do it. No big deal. Stream
Yeah.
should be up. Okay. X squared plus 1 over y. So separate your variables on any differential equation that you guys are going to be able to solve at this level. So move the ey up and the dx up, so you get e to the y is equal to x squared plus 1 dx. Integrate both sides, so hopefully it shouldn't be too bad. Plus x. Don't forget your plus c. As soon as you integrate, I always put it on the right hand side. As we've talked about before, it doesn't matter where you put it. I always just put it on the right hand side. That's a pretty common standard practice. Reminder, if you're solving for a particular solution or even a number like you are in this case, I believe it was, always use this initial value they give you to find your c as soon as it's there. Don't do any manipulation and then solve for c because it'll make your life a lot harder. So we know we get e to the, so x is 1, y is 0. So you get e to the 0 is equal to 1/3 times 1 cubed plus 1 plus c. So 1 is equal to 4/3 plus c, so c is equal to negative 1/3. And we are looking for what, f of 2? So you want the y value when x is 2. So you do have to solve for y at this point. So to do that, you would take the ln of both sides. So you get y is equal to ln of 1/3 x cubed plus x minus 1/3. And we're doing 2, so y of 2 is equal to ln of 8/3 plus 2 minus 1/3. So it's 7/3, 13/3. Whatever ln of 13/3 is. I'm assuming this has to be a calculated question, and yeah, it is.
It's 1.466.
Is that the correct answer choice?
Oh,
Yeah.
Yep. That's exactly what they got in the same everything, yeah. That makes sense, hopefully?
yes, that does. I was solving C, but I set like C, like I set the 1/3 x cubed plus x plus c just to 0. I didn't put it e to the 0. If that makes sense.
Gotcha. Yeah. Easy mistake. It happens. But like I said, always as soon as you take your integral, remember we talked about this, and there's a decent possibility you'll see some sort of differential equation on the test, to be honest, because it involves a lot of good concepts from calculus. As soon as you take your antiderivative of both sides, plug in for c at that point, because you do get points for solving for c. We call those initial condition points usually. So you, in this problem, you got for your first line here, you get 1 point for the first line, or the second line technically, the first line of actual work. That's, you get 1 point for separating your variables. Third line down, that's usually 1 point, if not 2 points, depending on how they award them, for finding correct antiderivatives. Then you get a point for solving for C using the initial condition. And then you get another point usually for finding like the answer type thing. So this is, remember, differential equations. Like solving it itself is usually about 4 or 5 points ish. And I feel it's probably gonna be on there because it tests like your antiderivatives and stuff like that. So there's quite a bit of things you could possibly do with a differential equation. So just try to remember this. Okay, so number 2.
A number two.
Yeah, I need it too.
Yes, damn.
Okay. Oof. I don't know if I like this one. Oh yeah, I do. Okay, that's fine. Yeah. Okay. Yeah. Okay. So it says the number of fish in the lake, of fish increase at a rate proportional to the number of fish present. Okay. So what does that mean when they say that the rate of fish increased at a rate proportional to the number of fish in there? It's the first thing I gotta make sure we understand.
Isn't it like the derivative or like the rate is equal to like this when it's proportional? So like it's one.
Yes. So the hardest part about that is setting up things. So dn, which I'm going to call the number, they used capital N. dt is equal to k n. And this is where you have to be careful and understand that n is the function of fish, the number of fish in there. So that's what that means. So the rate of the fish, rate of the number of fish, which is dn dt, is equal, it's proportional, so k times the number of fish. At that point, anytime we see something like this, we should hopefully know the answer to this differential equation pretty easy. You move the n over. It's one that we've done. K dt, antiderivative of dn over n. Anybody, antiderivative of dn over n.
ln of n.
ln.
Yep, ln of n. Antiderivative of k dt is
kt.
correct.
K squared. Wait. Oh.
Don't forget your plus c. Remember, k and t is the variable there, so it's just kt. Good job on that, Rudek. And then finish solving this, e both sides, you get e, oh, not you. You get that n is equal to e to the kt plus c, which is equal to c e to the kt.
Is it just KT?
On the right-hand side, kt plus c.
Or why is it KT? Like why is that the anti?
Because what is k?
Constant?
Okay, and then so what's the antiderivative of dt?
Oh, okay.
They're in this case, they're kind of expecting you to realize that anytime you have a differential function that's this, they kind of just want you to know that the answer is n is equal to e to the c to the kt. That's a pretty standard differential equation. That at some point they're just, I don't know if they're really expecting kids to 100% memorize that. I think a lot of teachers probably do teach memorizing that. You should be able to go through and find the antiderivative.
It's the constant times e to the KT.
Yeah. And they give you two constants, or they give you two of the variables twice, because you have two variables. C is a variable. Technically, it's a variable because we don't know what it is. And K is also a variable because we don't know what it is. So they give you ways to find it.
That's our formula. What numbers do we plug in to actually find that estimate?
You plug in 0 for T and 200 for fish. And then you plug in 2 for T and 1,000 for fish and solve for C and K. And then plug in 4 for T at that point. Because in order to find the estimate, you have to have C and K. So you got to solve it.
And when you just say it.
Yeah. So you plug in 0 for T. So they gave you the point 0, 2,000. Or was it? Yeah. And then, what is it? 2 0 to 100 and 2 to 1,000. So that seems a little high. So they gave you those 2 coordinate points. The reason they did that is so you can solve for c and k. So plug in, remember this is t comma n is the coordinates. So they just plug those in, so you get that 200 is equal to c e to the 0 t. So 200 is equal to c, because either the 0 is just 1. And then plug in your other one, see, then you get, I can kind of move that at this point. So 1,000 equals 200 e to the 2t. So 5 equals e to the 2t.
How do you find this?
2c, sorry, 2c, not, or 2k, not 2t. How do you find what's, sweetie? Okay. Then ln both sides divided by 2. So k is equal to ln 5 over 2. So your function actually looks like n is equal to 200 e to the ln 5 over 2 times t, and plug in 4. 5 over 2. And put that in your calculator, and you'll have your answer. Does that make sense to everybody, hopefully?
And now it does.
Okay. Number 3. Hopefully it shouldn't have been too bad. I don't know why they solve for C, but whatever.
How do you solve differential equations?
Separate your variables and take the antiderivative. So for number 3, you would multiply both sides by 2 cosine 2y and dx. So you get 2 cosine 2y dy equals 8e to the 4x dx. So basically bring your denominators up in this case. Then you, to get rid of your differentials, you have to take the integral of both sides, or anti-differentiate both sides.
So when you anti-differentiate this one,
Mm-hmm.
do you do that when you have all x's and y's on the same side, or?
After you've separated your variables, because you cannot take the antiderivative to the right-hand side. Obviously, that's just not going to happen. If you
Yeah,
could
so
take
you,
if you could take the derivative or antiderivative to the right-hand side, that's a really basic differential equation. At that point, you're really just finding an antiderivative. You're not doing a differential equation. Typically, when we say differential equation, we're talking about multiple variables like x's and y's, and solving for it. If you're doing just a regular one where it's like dy dx equals like x squared plus 5x or something like that, we don't really tend to call those differential equations. We just say that's a derivative. When we talk about differential equations, you have a funky function like this one. You're not going to get some basic thing. So like obviously sine of 2y minus 4 or 2e to the 4x is not it's not a typical function you would see. Because to graph that, there's like going to be a arc sine of e's and stuff like that. That's not a basic function. That's when we talk about having a differential equation.
okay.
Put the plus C on one side, right?
I just put it on one side, yeah. Usually put it on the side of the x. They solved for c here for some reason. I don't know really why, but doesn't matter. So they moved the antiderivative of 8e to the 4x will be 2e to the 4x plus c. And for some reason they moved the 2e to the 4x to the left-hand side. It doesn't, I don't know why they did, but they did. Okay, if you look at number 4, that's typically how you would see an answer as y equals. The difference in the why they didn't do it number 3 is because it would have been very messy and very ugly. So they just left it as the way it was. Typically when it says the general solution, if it's free response especially, you want y equals. If you don't have y equals on a free response, solution to a differential equation, it's probably not going to get you full credit. Any questions on number 4 or 3? If I needed to do it, because nobody said no.
3, good.
Okay, 4 we okay on 2, right?
4, I put the c outside of the square root. Should I
Oh,
see
no,
why?
no, no, no.
Like, I feel like it wouldn't make a difference though.
Makes a huge difference. That's like saying the square root of x plus c, and then the square root of x plus c, all under the radical. That's huge. That's like saying the square root of 5 plus 7, or we'll use easy numbers, the square root of 4 plus 7 versus the square root of 4 plus 7.
But I thought you would just account for the c not being in the square root when you solve for it.
If you account for it not being in the square root, that means you're adding it in after you're doing some algebraic manipulations. As soon as you take your antiderivative, you have to have a plus c. And that would be done before
Well, I mean,
taking
yeah,
the cube root.
that is. I did have to see it before the square root. I just didn't see why I did.
Yeah, as soon as you take that antiderivative, you've got to have that plus c.
Good.
Number 5.
I mean, all of these, I mean, I guessed on some and I got some, but I didn't know how to do them. But now I do. It's just, they're all the same, kind of.
Differential equations tends to be, yes, a lot of them are very similar. And let's see, looking at number 6, is this any different?
I need you to do number 6 because anytime I try to move the y over, I ended up adding it,
Gotcha,
and
gotcha.
then you can't do that. So
You cannot do that, that's correct.
I need you to separate that so I can see
Well,
how to do it.
I mean, you can do it, it's just you guys aren't going to do it. So this one is a little different than some of the others. So what was it, dy dt? Is that what it is? Yeah, minus 2 equals negative y. So you get dy dt minus 2 equals negative t. At that point, so you need to anytime you have really a differential equation at you guys' level, you want to get dy dt, the differential part, alone. So I would add the 2 over. Yeah, that's fine. Multiply by dt. Oh, yeah, it was equals y, negative y, not negative t. That would have made life a lot easier. Y. Multiply by dt and divide by negative y plus 2. So dy equals negative y plus 2 dt, and then divide by negative y plus 2. That's one option, depending on what they have for their answers. So that goes away. So you get dy negative y plus 2 equals dt. And then take the antiderivative of that on the left-hand side, which should hopefully be relatively easily familiar. So it's the antiderivative of the left-hand side. Hopefully the video's caught up by now.
Just negative ln y plus 2, or negative ln negative y plus 2.
Yep, negative ln of negative y plus 2 equals t. Move the negative over. Yeah, because I moved it over to the right-hand side from the beginning.
Oh, well, I guess that's equal to 2, because you took the integral with both sides.
Yep, I forgot my plus c. Do they give us any kind of thing, or are we leaving it with c's in there? That last line there, people tend to really not like. They did give us an initial condition y of 0 equals negative 3. So also don't forget that if you're not dealing with a specific solution, so they don't give you this initial condition, the 2 lines that I have there are equivalent.
Would the bottom be negative t minus c?
Nope. Would negative t minus c be wrong? Also no. But we also don't know what c is. C is just a constant. So negative c is just a c.
You divided by the ln, right?
I divide by negative. But
Sorry.
but what happens if I, same thing here, so if I take this and I was to multiply everything by 2, would I ever write 2c? And the answer is no, it's just c. It's always plus c because it represents a constant. Does it matter what that constant is? No. Now, if I solve for the constant in this first line, versus using my initial condition, versus solving in the second line, I will get two different c values. One will be positive, one will be negative, because it's been taken care of by multiplying by a negative. So either one I solve, I will get the same answer for c. It'll just be a different sign. So depending on which line I solve for, I always suggest, just so you don't make any mistakes, always solve as soon as you find the c. So I wouldn't have done this. If this was a, if I was leaving it as c, the bottom line would be great. But since I am solving for c, I'd put it in at the beginning. So you get y of 0, so t is 0, and then y is negative 3, so negative ln of 5 is equal to c.
The 0 is t in this case?
Yes, because your function is a function of y of t is equal to blah. So plug that back into that line, you get that ln of negative y plus 2 is equal to t minus ln 5. Minus ln 5. Sorry, negative t plus, I guess we'll do that, and then you get ln of negative y plus 2 is equal to negative t plus ln 5. E both sides, so negative y plus 2 is equal to e to the negative t plus ln 5. So you get negative y is equal to 5e to the negative t minus 2, and then multiply by negative 1, you get 2 minus 5e to the negative t. And yeah, I did it correct. Questions on what I did or how I did anything?
So when you raise the right side to e, you wouldn't be able to break it into e to the negative t plus e to the ln 5. It's
No.
multiplied.
It's the entire side has to be e to that power. So the entire power is the whole right hand side. And then you use the property of exponents to change it from e to the negative t plus ln 5 to e to the negative t times e to the ln 5.
Oh, okay, that makes sense.
It's like when you, it's the whole idea, same thing as, think about it like this way, as square rooting. If I square root the right hand side, can I do just a square root of t and then the square root of the ln part? And the answer I'm going to hope everybody remembers is no. Instead it is you have to take the square root of the whole thing. Same thing with raising e to the power. It has to be the whole side, not just an individual piece here and there. Any other questions on anything I did? Okay. Number 7.
Basically the same thing we did.
This one's a little different because we don't really, you're not going to be able to find the antiderivative itself of the square root of x to the 9th plus 1. So especially when you start looking at some of their answer choices, it should make sense that some of them are going to be correct and some of them are not going to be correct. So this is not a straight up antiderivative problem, which makes A and B not correct. And I'm going to hope that everybody knows right off the bat that those obviously are not correct answer choices.
what? So how would you know the difference between C and D?
So the important part and to remember is that the integral from 0 to x and the difference between the integral from 1 to x, basically. So if you do the integral from 0 to x, then you would get the antiderivative of x minus the antiderivative of 0. Well, we don't have the antiderivative of 0. We have the antiderivative of 1. That's why the answer is D.
This one you couldn't even really like do any work per
Nope.
se. Like you have to look at it.
Correct. And this wouldn't a question like this would not appear on like the free response necessarily because they're not going to expect you to write that derivative by hand. Now they do have you write differential functions and equations involving integrals, but really it just uses the FTC is what this is doing. So in other words, you have to remember that the integral from like 0 to x of lowercase f of we'll do f of t dt is equal to the antiderivative of f of x minus the antiderivative of 0. So if we're looking for the antiderivative of f of x, and this is like a function of like y primes and stuff like that, then this is y. So you get the integral from like 0 to x, f of t dt is equal to y minus f of 0. However, we don't have the f of 0, we have the f of 1, which is why that 1 has to be in the integral. If that makes sense. Hopefully. Maybe make it a little easier, so it's the integral of like y prime from 0 to x is y minus, y minus y of 0. I'd like to do a dx. Hopefully that makes sense. And then again, this is the part, so we need the 0 to be a 1. So it had to be the integral from 1 to x of y prime dx is equal to y minus y of 1. So y is equal to y of 1 plus the integral from 1 to x y prime dx. So that's kind of how they were expecting you to think of it. It's just a straight up FTC problem where they're expecting you to realize that you need the integral from 1 to something. Remember, I always give you that hint anytime they give you one function and they're looking for a second. The problem is the second one doesn't have an actual number. It's going to be a variable, and that variable would be x because you're looking for y of x. It appears as my mouse died. Oh, there we go. Okay. Number 8.
I missed this one.
This is like we talked about earlier where it says the rate of change of the mass, so that's like dm dt, is proportional to the mass, so equals km. So anytime you see that rate of change of something, that's, especially when we talk about differential equations, we're going to say that's like dm dt, especially since we're talking about like TUs in time. So as soon as they give you the function, the mass function is m, and you're talking about as a sample of time. And then rate of change is proportional to the mass is just km, like we talked about earlier on that one function.
Okay.
You know it can't be things such as A or C because that's proportional to time, and it's not proportional to time, it's proportional to the mass. So it's got to be B or D at that point.
Oh, okay.
D is where it's directly proportional, and C is where it's like inversely.
Yes, D would be an inversely proportional. Okay, number 9. This is the same thing I think we did on the one problem before. Yeah. So they've given you the differential equation here. So the dp over dt equals kp. Again, notice the answer being C is the exact same thing we talked about, where I don't know if they're really expecting you to solve or if they're expecting you to be able to just plug things in to the solution, because like I said, a lot of teachers will probably just teach students to memorize the solution to that differential equation there, because it's a common one they use in like actual application processes, to be honest. So a lot of teachers usually teach the memorization of that. I obviously don't. So take your antiderivative, plug in your 0 and 500, and then plug in your actually, you can solve for k, because they give you the decreasing at a rate of 11.5. So they actually give you a solution to the differential equation. So dB dt is equal to negative 11.5 when p is 50. So you can solve for k that way. In this case, you have to be very careful what information they give you and which equation to plug into. Do you plug into the differential equation, which is the one they gave you, or the solution? Does that make sense on what I just said, hopefully? I'll take this silence as a yes.
Kinda.
Okay. So again, just be careful. So if they give you time and an amount, plug that into your solution to the differential. And then the second information they gave you, where they give you the amount and the rate, obviously since it's a rate, that's got to go into your differential, the derivative.
What number are we on?
That was number 9 that I was talking about. Let's see, number 10. Wait, what? I have no idea how they expect you to know the answer to this. Like, reading
I
the
just
answer makes sense, but the fact they expect you to know these little things does not make any sense to me.
I just took the
Yeah,
derivative,
mine
like
switched closely.
found the second derivative of each one and then plugged in, and then whichever one was correct, that's the one I picked.
It's probably not a bad strategy.
It worked. So
What do you get? What? How? I just don't understand.
So she took the derivative and plugged in 3 and got 0. You also could plug into the actual derivative they gave you instead of taking the second derivative as well. Like, plugged in the values for W and dw dt. And see
No,
what's
I'm
on the.
pretty sure when you did that, they both were right, so you had to take the second derivative. Or maybe not, I don't know.
Well, all four functions are different, so.
Oh, yeah, well, I narrowed it down to A and C first. I don't know how I
I
got
knew
that.
the carrying capacity was bigger than 35 because the first derivative was not 0, but other than that, I had no idea.
Yeah, so picking out little parts of it, like some of it's, like I said, reading the solution is easy. Like I see how they did all that. I don't know why they expect you to know those little specific details there, though.
Yeah, the whatever 100, whatever 200.
Yeah. So they expected you to like plug into the actual derivative and solve for k. So yeah, I don't know how they expected you to know those pieces of information. That is kind of weird. But things you can do, like Rudek figured out, if you take the derivative and plug in the values for d squared, w, dt squared, that's one option. Um, let's see. You should also know that
It
the,
has to be A or C, right?
yeah,
Can't you eliminate?
so the rate of change of the weight, which is dw dt, is 6 when t is equal to 0 or when the weight is equal to 10. So either of those two would have been options. Since all of them say when the weight is 10 grams, that's talking about dw dt at w equaling 10. So that has to be 6. So yes, you can eliminate B and D by those choices there. So there's little small things you could do. I mean, it's a multiple choice question, so you're not going to see something like that anyway. So that's weird. 10.
I don't know why I didn't know how to do this one.
Did I miss going over? Because I mean, I didn't know we had to do logistic differential equations, to be honest. So that would be my fault, not yours. I didn't realize they were in. I must have missed it when I
That's
went over the
just
topics. So I'll get you guys some information. I didn't realize we had to do logistical differential equations, to be honest. That's my fault, not yours. So you wouldn't be able to do 11 or 10 or 11 or 12 possibly. Yeah, 12 is also a logistical differential equation.
For 11, I mean, this is definitely wrong, but it worked out. I just took the second derivative and then set it equal to 0, but I didn't plug anything in for dp dt, and then it still got me p equals 250.
I have no idea how you would have done
Yep, me neither.
that. So yeah, I will get you guys some information on logisticals and that you can basically just have written down for you, like facts and stuff like that. Um, and then I don't know, it's a small portion. I don't know if it'll be on BC, to be honest, but I'll get you some information that you can have on your note sheet, which obviously I'm going to assume everybody realizes they should have a note sheet at this point. If you have not figured that part out yet, I'm giving you explicit instructions to have a note sheet for things. College Board expects you to have a note sheet. Like legitimately, they have a thing on their website that says helpful hints for taking open note tests and things like that. So, and I'll make sure you guys have stuff before the exam. 12, which fun could be. So this one shouldn't be too bad. You should be able to pick out things based on the slopes of the graph. So you should realize if the slope starts at a maximum, starts at a minimum type idea. It definitely won't be D. Let's see, this is going to have, so as y gets bigger, so the y value itself won't go above 20. It'll start out positive. The slope will start out positive, so it has to be either B or C or D, but D is just wrong. So the question is, where does it start? And that would be low, so it should be C, I think. Yeah, it is. Well, like I said, I'll get you information on logistical differential equations. That's my fault, not yours. I guess I just missed that topic when I reviewed everything at the beginning of the year. So I do apologize. Outside of logisticals, shouldn't have been too bad. The first like 9 questions I hope weren't that bad. But I do remember you guys last year struggled with differential equations, to be honest, so. How did the multiple or the free response feel for everybody?
I did the first one or two questions, and I don't think they were that, like, I didn't get every single part, but they weren't that bad.
All right, for AFT, use a tangent line. So the first one they have you using a tangent line. That's not bad. We should be able to do that, hopefully. Show that A of t satisfies the differential equation. That's not too bad. Just take the derivative and show it equals. It's pretty straightforward. That shouldn't be too terribly bad on number 1. Not the easiest things in the world, but not terrible. Oh my god, slope field. Ah!
So what was the answer?
To which part? Or all of them?
Like the equation and at time equals 7 days.
So for A?
Mhm.
Hold on, I have to pull open the scoring thing. So the answer is supposed to be 16.
Okay, good.
Slope field shouldn't have been too bad, I hope. Second derivative should be straightforward. Determine the concavity of all solution curves. I'm assuming it's probably always concave down or always concave up or something like that.
Oh, are you on number 2?
I was just looking at the questions real quick, yeah. I wasn't going over them yet. I just wanted to see how they looked before we did anything. Since we're almost out of time, I don't know if we'd have time to even finish
Are
the
we
full
gonna go over them tomorrow?
one. You have burst tomorrow. We can't do tomorrow, so I was going to do it on
Oh,
Monday.
junk, I forgot.
Yeah, so I was going to assign section 8 and then go over these on Monday. I was just looking at them real quick to see how they felt.
Okay.
That way, if you guys needed to go back and relook over anything on the FRQs, if you had any questions, you could. So I just kind of wanted to look at them and see how they were.
We could do one right now. There's only 3 parts.
Okay, sure. So number one hopefully should be pretty easy, tangent line. So what information do you need to write the equation of a tangent line?
Slope.
Point slope.
Yep. And they gave you a point, I think somewhere in there. Yeah, t equals 5. There are 10 million cells. So they give you the point 5 comma 10. Is it measured in millions? Yeah, measured in millions. So you get the point 5 comma 10. So you have that point. You have the derivative, so you just find your slope. So you should have gotten a value of, looks to be 3 for the slope. So the equation of your line should have been y minus 10 equals 3 parentheses t minus 5. And then plugged in 7 and got 16. So that part should have been super easy for you guys. Part B, so if you're showing that, be careful, always make sure you read the words properly. If you're showing that satisfies the differential equation, basically just take the derivative of what they gave you and plug everything into the derivative equation. So when you take the derivative of that, you plug that in for dA dt, then equals, and then you basically just manipulate it to get to where you want. And you do need to verify the initial condition. That's something you guys might not have done. So make sure you plug in, since I gave you the initial condition a of 5 equals 10, make sure you plug 5 into their original equation, the a of t function, and make sure your answer is 10.
So we're supposed to take the derivative of a of t and then set it equal to t minus 1/5 a?
No. You take the derivative and manipulate it to get t minus 1/5 a.
I just didn't know where the a would come from because when you derive it, or when you take the derivative, there's only t's at that point. Right?
We'll have e's and stuff like that.
But there's no a, so how would you even manipulate it to get that 1/5 a?
Because you should be able to make that connection. That 5 plus 10, you should be able to show that that is equal to 1/5 of that through algebraic means. Okay, I guess what they did is they actually showed, they took the derivative. So you did what they, yeah, you're right. I would not have done it that way. When I read the question, that's not what I would do. So they take the derivative and they get the 5 minus e to the 2 negative 1/5 t, blah, blah, blah. They get the derivative, which you guys, I'm sure, can do. And then they do t minus 1/5 a, and they show that those two things are equal. That's what they did.
Okay. But then do they plug in for a? Is that what they're doing? They just
Mm-hmm.
plugged in 10 for a?
No, they plug in the function for a.
Oh,
So t minus 1/5 of a. A is a function. You got to remember that. And they give you that at the very beginning of the question. So the first part they have you do is take the derivative of a of t, which they give you. Then they look at the value, they figure out what the value of t minus 1/5 a is. And they show that those two things are equivalent. And that's showing that that's there. It's not how I would have originally, or how I personally would have done it, but that works.
okay.
So it's a little funky on the wording in my opinion, but whatever. And then C, looks like they're having you solve the differential equation here. Yep, so they have you solve this differential equation. So you have to separate the m and the t. Remember, k is a constant, so that's going to be left wherever it is. Usually we leave the constants and things like that on the side of the t variable or x variable, whatever the one is. So all I would do here personally is divide by m and multiply by dt. So dm over m equals negative 1/2 dt over t plus k. So basically you switch the m and the dt in this case. That's through algebra, you can do that really easily. Antiderivative left-hand side should be pretty easy. That's your ln of m. Right-hand side it will be ln of negative 1/2 ln of t plus k. And then don't forget your plus c, solve for your c at that point. They give you the time. They give you 2 different points, so you're going to do the same thing we did before. We're going to plug in twice and solve for K in 1 and C in 1, which is dumb, but whatever. Not the easiest differential equation, but not the worst one either. I'm assuming 1 point n is... Yeah, so you're basically going to end up with a system of equations. You have to solve for t and solve for k. Yeah, this is not the easiest of questions, to be honest, with the way they do things. I've never seen an equation like this. Okay, so things to point out here and ways you can get points. Remember, you get points for separation of variables, doing your correct antiderivatives, and plugging in to find like your constant. So things like that. So even if you can't remember, get to the full final answer, you get points for doing what you're supposed to do along the way. So those are things you want to focus on. So everybody can separate their variables, hopefully. Everybody can take their antiderivatives here because they're not too terribly difficult. And then you can plug in your initial conditions. Plugging in the initial conditions on this question is definitely not the easiest of things because there's a variable inside of the function because they put that k there. That k does throw a monkey wrench in. In case you want to try to get the full answer, it is 30 over square root of t plus 1.
Is it t plus 1 all in the square root?
Yep. So basically your k value ends up being 1. That's how that works. Okay, so that is not a fun question. Right, and then before anybody even goes anywhere today, I will assign section 8. People not even telling me I didn't assign anything last week. I see your plans.
I mean, to be fair, I didn't know you didn't assign anything until you said you did at like 10 o'clock that night.
So what was your plan, to wake up in the morning and do the assignment, Tanner?
I was genuinely planning to do it at night. Just I wasn't done playing video games.
You're almost as bad as me.
I stayed up till 2:30 last night playing video games. I was like, I really need to go to bed.
I was up till 4. So yeah.
Jesus.
I was watching TV though. I wasn't even doing. I think it was like 5. But I just couldn't go to sleep. Okay, assigning part 8 now. Yeah, so a couple more sections and we're done. And then we'll do like a mock exam from somebody and we'll kind of go over things like that and that'll be it. We're done. You have what, 2 more full weeks of me.
Lord.
So please make sure this stuff is done by Monday. We'll finish going over the FRQs real fast. So if you have any questions on any of them, make sure you go back and look at them. And we'll finish up the FRQs real fast and then jump to the multiple choice. Let's see if it'll load a little faster. There should only be 2 parts of the multiple choice if I remember correct. Other than that, you guys have a good day and enjoy Ms. Burris' class tomorrow.
I will.
So, for Monday, do you want multiple choice or like
I would
Unit
assume
8 multiple
we'll
choice stuff?
have be able to go over part A on Monday, so you should have part A done. Because there's 2 parts to it, so I would assume the plan would we'll finish FRQs because only 2 questions, and then we should probably be able to get at least most of the way, if not all the way through part A.
Bye, everyone. Have a good weekend.
Bye, you too.
Bye
Well,
bye.